Okay, as promised, we are continuing on with 12-2. Three. I think it's 3. Continuing on. I think it was 3. So we were in discussion with a lot of this stuff. So one of the things, I think we were ending on talking about exact values. So anytime they say exact, or anytime you have an angle measure that deals with the 30, 60, 90, or 45, 45, 90, the expectation is you could put exact trigonometric values, meaning no decimal. So with that being said, if I were to state, hey, what is the sine of 26 degrees? Give me the exact value, meaning no decimals, possible or not possible? Not possible, right? So if I were to give you sine of 135 degrees, possible, because we think of, as we're starting to think about this, our unit circle. Now 135 is not a 30, 60, 90, 45, 45, 90 in quadrant 1. But 135, if you think about it, you would come over 90 degrees, and then how many more degrees? 45 more degrees. So 135, is actually a 45, 45, 90 triangle. Therefore, you're like, okay, 45, 45, 90 in quadrant 2. And so maybe we just break it away from that. It is important to make a note, though, that it is in quadrant 2, meaning to get up to if you were to think about going out to this coordinate point out here, to get that direction, my x is positive or negative? Negative. My y is positive. So when we think about the sine of 135, you're really just asking what is the sine of 45, but then you have to pay attention to, might it be a negative ratio or a positive ratio? And as you memorize, we know that sine, and that's fine, you can think of like sine of 45 as SOHCAHTOA, like I said, or remember that sine is y over r, therefore y is positive. So this value will be positive, and then what's the ratio formed? Well, all 45, 45, 90 triangles are going to have some sort of root 2 in them. Yes. And like we've discussed briefly, but the easiest r value to deal with is 1. Again, you could pick, if you're like trying to do this longhand on a test or something, you could pick, I don't know, there's no value. Well, pick any value you want for your hypotenuse, it's usually the easiest, and then go from there. And you're like, okay, 7 is my hypotenuse. Fine. What is this value here? 7 over root 2, which would be equal to 7 root 2 over 2. So then you say, okay, sine is my y value. So you just said this was 7. You said this is 7 root 2 over 2. Your sine is y over r. So your y value, 7 root 2 over 2 divided by 7, divided by your r value, which is just going to cancel, and you end up with what?
Root 2 over 2.
Root 2 over 2. So it's just easier to memorize it rather than trying to do the ratio. Just memorize it's root 2 over 2 every time. Because it doesn't matter what we put here or here. That's why we talk about the unit circle having a radius of 1. Because then you're always dividing by an r value of 1. Which means your sine value is whatever is here, which would be 1 divided by root 2, which is root 2 over 2. So that's your that's your y value. Now, this value here, typically, we learned, in the basics of geometry, root 2 over 2. But then we say, oh, well, what happens when it's 135 degrees? This becomes negative. So then we say, what is the cosine of 135? That is x over r, and since it's going this direction, it's a negative root 2 over 2. And then we say, what's the tangent of 135? Well, tangent is simply your y over your x, which is the same thing over the same thing. It's going to be 1, except it's a positive over a negative, so it will be negative 1. So with a little bit of practice, a little bit of understanding, you can no longer have to memorize the unit circle by saying, okay, there's a pattern, 1/2 root 2 over 2, root 3 over 2, back to root 3 over 2, back to 1/2, back to root 2 over 2, and then it changes to negative, and you can memorize the pattern and go in the circle, but you have no understanding. And that works. It'll work for the unit circle quiz, no problem. But with a little bit of understanding like this, you can, as you go, you're like, okay, anytime I got a 45, 45, 90, I know I'm going to have a root 2 over 2 in both spots. And remember, any coordinate, well, any angle is always written like this on the unit circle, and it's x comma y, right? So in quadrant 2, your x's are all negative. And therefore, it's really written as whatever the cosine ratio is and whatever the sine ratio is what you're looking at for those coordinate points. So it's always cosine comma sine, because cosine is x over r, sine is y over r, which is x comma y. So that helps us in the unit circle. So when they say exact values, it'll always be one of those angle measures on the unit circle. They'll never have 17 degrees, 142 degrees. They'll never have that and ask for the exact values. That's in 12.4. They just have, oh yeah, use your calculator, hit enter. That's 12.4. So, and then remember, the 6 trigonometric, we have sine, cosine, tangent, and then we talked about yesterday, cosecant, secant, and cotangent, right? So if I say, all right, sine is root 2 over 2, what's its reciprocal? Not its inverse, what's its reciprocal? Sine of 135 is root 2 over 2. Its reciprocal would be labeled as root 2 over 2. Cosecant of 135, and that's equal to 2 over root 2, which is equal to 2 root 2 over 2, which is equal to root 2. So you got to know your reciprocals. Just flip it, right? That's all the reciprocal is. Flipping it. So then you go through and find your other values that way. Okay, so exact values always are referring to the unit circle. Okay. Now, there was one other, there might be a couple other things. One thing that we did not discuss, which was what happens when, so we talked about like a 30-degree angle, a 60-degree angle, a 90-degree angle, all those. Now, we didn't talk about the 90, that's what I'm getting at, is when we looked at the 30, 60, 90, right, you have this triangle that's formed, or a 30-degree angle, you're making a 30, 60, 90. What happens when your value is no longer, because if you think about this, like we discussed, it's, like a circle, right? So you're the R value, here's your Y value, here's your X value. What happens on 90 degrees if I said, hey, what is the sine of 90 degrees? Well, sine is equal to Y over R, correct? So if you think about your R value, as you're rotating, it's at 30 degrees, and then 31, 32, up to 45 degrees, 46, 47, 50, 60 degrees, right? 70 degrees, 80 degrees. My R value compared to my Y value, if I were to draw like another triangle in here, like this, there's my R value is out to there. My Y value is, oh, Dad, hey. Oh. Happy birthday. Oh, awesome. Mom said if I don't want the packaging.
You get to him happy birthday.
Really? Happy birthday. It was a while back. Here, Mom said to send the packaging home with you.
Well, you got to hurry.
Well, can I just send this home, or should I just give it to you later?
No, you should, the surprise of seeing what's inside it.
Well, I might have seen the receipt.
I would assume it's not fragile.
Not fragile. Okay. Really? I should have done this for the camera. Wow.
Some box.
Okay. Let's show everybody. For anybody that knows anything about tennis balls.
Oh, yeah.
These are the best of the best.
Okay.
So it's a big deal.
Right.
That's sick. If you don't know much about tennis balls, or you wouldn't understand, you'd be like, okay, tennis ball.
Definitely wouldn't pay the money for those.
Do I? No, because when you crack them open, they lose their value. Yeah, thank you.
Adios, happy birthday.
Thank you, love you. Wilson US Open. So you can buy pen, is like a standard brand,
Yeah.
and that's a good economic way to go. A pen can would be like, maybe like $2.50 a can. Wilson US Open's now like $7 per can.
Really?
Yeah, but there is a
Yeah.
difference if you
Really?
play
Okay.
and the biggest difference is out of the box they're both going to be a similar bounce right out of the can. They're going to be fairly similar. You play with a pen ball within a half an hour of hitting, it starts to lose that bounce. And if you're into playing tennis, a dead tennis ball is not a valuable tennis ball. It doesn't represent actually playing.
Yeah. Wait, just a half hour.
Yeah, like, good hitting.
Yeah.
Now, dinking back and forth, you don't really care too much what the tennis ball is. But if you're really trying to get, when you're playing, that ball will lose its pressure. And then, which is nice for some people, is that when the ball's lost pressure, you can hit it really hard and it doesn't go as far.
Yeah.
So then you can really, but then the problem is if you go to actually play a competitive match, they're going to open a new can of balls. You're going to go to hit it the same, with the same hit, and it's going to send the balls flying.
Yeah.
So in the end, you really want to play with pressurized.
Wait, is that what they come in a pressurized bottle?
Yeah,
So they don't lose pressure.
yeah.
Wow.
And then if you crack them open but never use them, they'll lose their pressure.
Oh.
I don't know what the time frame is, but they'll lose their pressure. But pen balls after, you can play for an hour, and then bring them back a few days later, play for another hour with them, and then you'll notice a drop off in its real value, and you can tell just by squeezing it or hitting with it. But the Wilson US Opens will last you, probably easily 3 or 4, double the amount of time. Plus, if you open them, play with them once, and then a week and a half later, you get around to playing again, they still have good value.
Yeah.
Versus a pen ball, you play with it, a week and a half later, you come back to it, it's lost that. It's it's a little bit depressurized or dead, you would call it. Which again, I'm not a tennis snob, but if you're going to be playing, you're trying to get better, you want to be able to play with what you might play with in a match. Plus, when they're pressurized, you can hit it and they go faster. And
Yeah.
just playing with the right equipment.
Yeah.
It'd be like shooting a basketball, like a flat basketball. Maybe
Yeah.
it's a big analogy. It hits the rim and then always goes in.
Except it's a basketball that you
Yeah.
can't replay.
Yeah, it's just kind of you want to play with what you're going to be using in a game.
Right.
Or oh, this is great. I can shoot a mini basketball.
Yeah.
I don't know. Anyways, so these are, but they're so expensive. 24 cans. But they're so expensive now. So that's a nice birthday gift.
Yeah.
I don't know how much they are in bulk. I didn't look it up. I was too embarrassed. It's you feel bad when
You
you
can
get
put
really
it on
expensive.
extra credit and have us do it for you.
Right. Okay, so we were stating that right here, my R value, if you look at the green one, the R value is quite a bit bigger than the Y value. It's actually double, which we know that because it's a 30 degree, at least the green one right here. But as my angle is increasing, right, my R value right here is becoming very similar to my Y value, right? So that ratio, this ratio is getting closer and closer to what? Any guesses?
1.
1. Yeah, you bet, because the R is about the same length as the Y. And if we like erase this, and we made it even like closer, there's your R value, and you're trying to make a right triangle. Your R value and your Y value are almost the exact same thing. When they're almost the exact same thing, they're really getting really close to 1. Then what happens when you hit 90 degrees? Yeah, you don't have a right triangle anymore, but your R value going out to the edge of the circle right here, and your Y value, like on an XY plane, to get out to that spot, they're the exact same. So your coordinate point right here is over 0 up something. It doesn't matter your R and your Y. I put R slash Y. Maybe I should just put R is equal to Y at that point. So if your radius is 10, well, you go from here out to there, it'd be over 0 up 10. So your Y value is 10. Therefore, the sine of 90 is the same thing over the same thing. So what's the sine of 90 always going to be?
1.
Y. I mean 1. Yeah, 1. So what is the cosine of 90 degrees equal to? Well, cosine is, what's the ratio of cosine? What in variable form? X over R. What's the x value? Always at 90 degrees. It is always 0. It doesn't matter what the radius is. 0 over R is 0. So when you look at your unit circle, right, at the top it says 0, 1. So then when you come out here, think about this, to go at 180 degrees. Now, your coordinate point is something comma 0, right? Because your Y value is 0. This, meaning your R value, to get out here, R is almost equal to X, but there's a slight difference. Because what is X? R will always be positive. What is X out that way? Negative. So R and X are the same, except it's going to be a negative X.
Yeah.
So they don't quite equal each other. Therefore, out here, if you think about that at 180 degrees, let's think through this. What is sine of 180 degrees? Now remember, sine is Y over R. So what is your Y value at 180 degrees? 0. So 0 over whatever is 0. So sine of 180 is 0. And then cosine of 180 degrees is equal to X over R, right? But your X in this case is going to be negative. So again, if your radius was 10, this would be like a negative 10 comma 0. Your radius is 10, your X value is negative 10. Just doesn't matter what you choose, negative 10 over 10 or negative 5 over 5. But your value will be a negative 1. Cosine of 180 is a negative 1. And then let's keep going around. Your coordinate point here is at 270 degrees, right? Your coordinate point, what's your Y value? Let's start with it. 0, right? Y value, no, I'm sorry. X value is 0. Your Y value is negative Y, like you were stating, right? So it's a negative Y. Therefore, what is the sine of 270 degrees? The sine is Y over R. So it's your Y over your R. They're the same thing except one's negative. So therefore, it will be negative 1. What's cosine of 270? 0 over R. So it's going to be 0. And then the last one, or you can think of it as the first one because we didn't actually talk about it. To come out here, this is either considered 360 degrees or it's considered 0 degrees, right? So 360 and 0 are the same thing. So you can either say, hey, what's the sine of 360? Or what's the sine of 0 degrees? They're both the same thing. Okay, so they're both equal to the same thing. So when you think about that, your x value is the same as your r value, and they're both positive, and your y value is 0. So when I talk about the ratio there, what's the ratio? Well, sine is y over r, so it's 0 over r, so sine is 0. Cosine is 1, right? Because it's r and x are the exact same thing out of that spot. Now, we didn't talk about tangent, so let's talk about tangent at all these spots. Let's just throw this over here. By the way, maybe we should talk about this too. The reciprocal. Sine of 90, let's say. What's the reciprocal of 1? 1. So the cosecant of 90 is 1. But what's the reciprocal of 0? Can't divide by 0. Therefore, the reciprocal, so secant of 90 is equal to undefined. Because remember, cosine, or like secant of 90 is the same thing as stating 1 over cosine of 90, which 1 over cosine of 90 is 0. So reciprocal of 1 is 1, reciprocal of 0 is undefined, reciprocal of 0 is undefined, reciprocal of negative 1 is negative 1, reciprocal of negative 1 is negative 1, 0 is undefined, undefined, and 1. So reciprocal is that way. Tangent, let's go tangent, let's list off all the, we'll start at 0, which is also the same as 360, and then we'll go tan of 90, tan of 180, and then tan of 270 degrees. Okay. So think about tangent. What's the ratio in terms of x, y, and r? What's the ratio for tangent? Y over x, right? So when we say y over x, you think about at 0 degrees. Okay. It's y over x at 0 degrees or 360 degrees. What's your y value there? 0. Your y value is 0. 0 over whatever x is, doesn't matter. What's 0 divided by anything? 0. Unless it's 0 divided by 0, so it's 0. Reciprocal, so cotangent of 0 is undefined. Tangent of 90, again, it's y over x. My y value is whatever it is, y, divided by my x value, which is 0. So what is the tangent of 90? Undefined.
So then, when we do cotangent?
Cotangent of 90, because it's the reciprocal, it's actually x over y.
Oh.
And so in that case, x divided by y. So cotangent is actually 0.
Okay.
Yeah, it's kind of tricky.
Yeah.
Yeah, but cotangent would be 0. All right, tan of 180. Tan of 180 is my y value over my x value. So therefore it is 0. Tangent of 270. Undefined. Okay. Making a little bit of sense, possibly. Okay. So there is 2 examples I want to give, or maybe a little bit more than 2. I'm going to, let's do this, make this, the question is, name all angles. Okay, so this has to do with not just what we talked about, but some other parts of what we talked about, the reference angle yesterday. So name all angles that work for this between 0 degrees and, they use theta for that, okay, and 360 degrees. Because we remember, if they didn't put 0 and 3 to 360, you could just keep going around and find an infinite number of angles that work. Because in a circle, right, 360, we talked about that yesterday. I think like you go 400 degrees. I'm sorry, you go, yeah, 400 degrees, it's the same as 40 degrees. 440 end in the same spot. So if you look at this, it says name all angles. So if I give us sine of theta equals 0 degrees. Now this is classic. I'm sorry, not 0 degrees, sine of, because theta is the degree measure. What I mean by classic is this. People will, because in 12.4 we'll review how to use our calculators, which you probably have a little bit of ability to. People are like, oh, I'll do inverse sine button on my calculator. If you recall the inverse sine button. People say sine to the -1, it's called inverse sine. So you could do that, that's fine. I'm not restricting the calculator. And so if you hit inverse sine on your calculator, you're going to end up with 0. So you're like, oh nice, theta is equal to 0 degrees. I will give you, actually on the test, I'll probably give you no credit for that. Because that's not what we're testing. We're not testing your ability to hit a button on the calculator. Sometimes we are. In this case, that's not the point. The point is to understand that sine theta is equal to 0 in more than one spot. The calculator tells you it's equal to 0 at 0 degrees. Where else is sine theta equal to 0? What? 0 degrees, because sine is y over r. So where's your y value 0?
On the other side.
On the other side. So where else? 180 degrees. And this is what we're really testing. Not your calculator, that's calculator work. Your understanding actually comes right there. Okay? So another one though, like along the same lines, let's go with sine of 30 degrees. I'm sorry. Let's go sine, actually let's do this. Cosine of theta, because we haven't used cosine in a little bit. Cosine of theta is equal to root 2 over 2. Now what that tells you is, oh, what kind of angle measure are you dealing with? 45. So cosine of 45 gives you root 2 over 2. Hit inverse cosine on your calculator of root 2 over 2. What should it give you? It better give you 45. Yep. Okay. Again, would I give you any credit unless I was testing you without a calculator? If I was testing these without a calculator, I would give you partial credit for writing 45 because you have that memorized, you know that. Your full credit, or any credit on the test, because I let you use the calculator, is going to come from what? The next spot where you know cosine is equal to root 2 over 2. Reference angle tells you 45 degrees. Let's look at a picture here. 45 degrees refers, what? To how many spots? This reference angle of 45 degrees refers to how many different spots? Here, and here, and here, and here. However, how many spots is cosine theta equal to a positive root 2 over 2? Because we know root 2 over 2 is happening here, 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 and here. However, depending on which one we're looking for, the y or the x, it will matter which one's positive, which one's negative. So cosine is positive in which quadrants? 1 and 4. So we say, oh, we're not looking at this, we're not looking at this, we're looking at here, and right there. What's that angle measure? 315. 315. So 350, because you just subtract from 360. So you get 315 degrees. So that's where you're going to get 4 points from. Now you have to include both, but the calculator gives you the 45. I'm going to be asking for the full shebang. So let's try this one. Cosine, now try go no calculator on this. And the reason why I can say no calculator is what kind of ratio is this? This is what I call a unit circle ratio, right? So unit circle ratio, unit circle ratio, unit circle ratio, these are all non-calculator based problems. Guys, and tomorrow in 12.4, if I asked you, hey, cosine of theta is equal to 0.629. Is 0.629 a unit circle value? No. So that's absolutely, you have to use a calculator to get what the angle measure is and then follow the process. We'll talk about that tomorrow. But negative root 3 over 2, that tells you unit circle, root 3 over 2, where is cosine theta equal to root 3 over 2? I'm going to erase this. Think unit circles, we have here. Let's start with the negative portion. Which quadrant am I in when cosine is negative? Quadrant 2 and 3. So you know you're going to have two spots where it's negative. So you're going to have two answers. And it's at root 3 over 2. So are we dealing with 45s or 30s, 60s, and 90s? 30s and 60s and 90s, right? So you can say, man, I just am a little confused which direction I go. If you just memorize this 1, 30, 60, 90, the initial one, like that, cosine of 30, I mean, you'd have to memorize this. What's the cosine of 30? If you peek up at the unit circle, what's the cosine of 30? Root 3 over 2, right? And then sine is 1/2. Most people have sine of 1/2 memorized only because I give it to them often in the beginning of discussions. But, okay, so if you know in this 30, 60, 90, cosine's root 3 over 2, again, what am I looking for? Root 3 over 2. What am I going to be messing with a triangle that looks like that? No. Which triangle am I going to be looking at? Like that, right? The mirrored one. Somebody said that the other day. Yeah, perfect. So in other words, and I don't want this one, I'm looking at to get to here.
And the one below.
And then the one below. What's the angle measure here? What's the angle measure here? 30. So what's the angle measure here? 30. Sorry, what's the angle measure here? 30. So to get to right here, what's that angle measure now? 150. So I know 150 is the angle measure. And then what's the next angle that I get to? So you go all the way over to here, 210. There you go. Now you can confirm this on your calculator by hitting cosine of 150. Some calculators do simplest radical because their unit circle stuff is programmed in there. Others will give you a decimal, but if they give you a decimal, all you do is you're like, well, does the decimal answer my calculator give me this? So cosine of 150, enter. It gives me this, negative something. Check your decimal value of the root 3 over 2. Okay. Does that make a little sense so far? Okay, now I need to do one more example, maybe two, but so that takes care of those two angle measures, so you're good there. Now not all, okay, erase this, not all of them will have two answers, meaning, if I said cosine theta, so I just kind of gave it away, I tipped my hand. Where does cosine theta equal -1? So without a calculator, let's think through this one. Where does cosine theta equal -1?
Bottom one.
180. Think about cosine. It's x over r. So where's your x value and your r value the same thing but negative? So you think about, you have a circle. Where's my radius and my x value going to do the same thing? Out that direction, right? Yeah. So in other words, theta is equal to 180 degrees, but there's not two answers because the opposite would be +1. Down here undefined, up here undefined, because your x value is 0. I'm sorry, not undefined, but 0, your answer is 0 for here and here, because your x value is 0. So yeah, this is a positive one, this is your negative one, so how many spots are there? Just one in that case. But anything, otherwise it's always going to be 2 answers, like we're finding on those ones. And again though, there was 2 answers at the 0, even though that's on an axis like this. Because where does cosine theta equal 0? Well, here and there, because your x value is 0 in both those spots. Okay, last one is, it says, first, give the quadrant for theta, then find 5 other, sloppy, 5 other trig functions. So you're going to be given this, sine theta is equal to -4/5. Now, we're going to look at this for a second. If I gave you sine theta is equal to -4/5, unit circle or not unit circle? Not unit circle, right? -4/5. Do you see that anywhere on the unit circle? No. So this is not a unit circle, but what they're not looking for theta. What they're looking for is, they say the 5 other trig functions. They're looking for cosine theta equals what ratio, tan theta equals what ratio. They're not looking for theta. And then they're looking for cosecant theta and secant theta and cotangent theta. You don't have to put it in this order. You could put, sine, cosecant, cosine, secant, tangent, cotangent, whatever. I'll probably give you an order on the mid-chapter assessment so it's all organized so I can easily grade it. I'll probably give you a box with like these on there and then you just plug in. So what they're looking for is the ratio. But we know, hopefully we know, and they give you a tip, hey, give the quadrant for theta. Meaning, where is the angle measure? Just the quadrant. So we think about, we draw, okay, -4/5. Where does sine theta equal? What they're asking you to pay attention to is not necessarily the 4/5 really yet. They're asking you to pay attention to the negative. So where is sine theta negative? 2 or
4.
I'm sorry, 3 or 4, right? Well, the issue with that is you're like, well, that's good and well. I could write 3 or 4. It's one of the two. Because I could either, remember, you're stating -4 for y and then 5 for r. So it's like, out 5, like this, and then a -4, or like this, it's out 5 and then a -4 there. One of the two, that's what it looks like. So that's an issue when you say, well, if I wanted to do cosine, well, cosine is positive here, negative there. So which one is it? And that's where they give you this. They say theta, they give you a little more information, is between 90 and 270 degrees. So what they want you to analyze is the angle measure is going to fall between 90 and 270. So where does it fall between? 90 and 270. Therefore, which quadrant is it in? It's in 3. We're not going to consider that. So now that tells you when you go to cosine, x is negative, right? So now you think, okay, well, I know I have a -4 for y, I have a 5 for my r. What is my x value?
3.
And then -3. How did you get 3 so fast?
Because it's the perfect
Pythag triple, yeah. If you didn't know it was a Pythag triple, no problem, just do the Pythag theorem. The challenge is remembering that when we talk trigonometry stuff, x can be negative. So when you do Pythagorean theorem, you would have ended up with a positive 3. But then you're like, oh yeah, but I'm going in this direction, so it's a negative 3. And now I just fill in my ratios. Cosine is x over r, so it's going to be a negative 3 over 5. And then tangent is
Positive 3/4.
y over x, so it's going to be a
4
positive
4/3.
4/3. Why positive, not negative?
Yeah, negatives cancel each other.
Yeah, it's a negative and a negative. Remember, this negative, yeah, it's written on the out front, but which is applying to? The numerator or the denominator? Numerator in this case, it has to, because we're talking about a y and an x, and then the r is always positive. So then what's cosecant? Just reciprocal of
Yeah.
something.
Negative 5/3.
Negative 5/4. Good. Why do they have to do that to us? They do. Cosecant and sine work together.
Oh,
Not cosecant and cosine. Yeah.
I think you came up with a new one. We call it cotrecant. The top one.
Yeah.
Co-3cant. Yes, that is. That is a 3. You can't deny it. Co-3cant. Co-3 theta. Very good. So then what's secant? Remember, secant is the reciprocal of cosine. So negative 5/3. If you wrote 5 over a negative 3, I'm not going to mark you wrong. And I actually wouldn't mark you wrong because technically the ratio is going to work out in the end. Negative 5 over 3, I'm not going to mark you wrong. But the negative is really being applied to the 3 there. And usually we just write it out front. So I would accept any of those. This is optimum. Mathematically understanding it, there. Not quite understanding it, but I'm not going to mark you wrong. Decimal answer is the same. Cotangent? I'm sorry, not 4/3. Okay. So that takes us right up to the end there. So let's say 12/2. What do we have here? 12/2 is due tomorrow. 12/3 will be due on Thursday because everybody has to catch up to speed on that, so it'll be due Thursday. Also, unit circle quiz tomorrow. I'll discuss the radians and how to memorize pi over 6, pi over 4, because it looks a little complicated. Because there doesn't appear to be a great pattern, but there's a really nice pattern too. So I'll discuss that. So hopefully, even if you forget to memorize it, no, unit circle quiz will be Friday maybe.
Okay.
Because tomorrow I'll give you how to, you can memorize the radians without the pattern. You just memorize there's a pi over 6, then a pi over 4, then a pi over 3, then a pi over 2, and then 2 pi over 3. It starts to get, you can memorize that anyways, but there is a reasoning, a mathematical reason behind it, so that when you're like, oh, it's either out of 6 or it's out of 4ths, and as soon as I get my unit circle, I'm just going to write them all down out of 6, out of 4, and then I'll have all the correct ones.
So what are we putting on?
Oh, nothing tomorrow. But I don't think because you were gone yesterday, I think that's going to hand out and I also have, this is the quiz on Friday, which you can get also filled in from other people. Front and back is necessary. But some of the parts were from the lecture yesterday to fill in on the very back bottom. And then everything else either needs to be sorted through on your